All right, so today we learned about simplifying functions with negative exponents. And so our example was x to the negative 1 plus y to the negative 2 all over x plus y. Now, our goal is to make this into something that is a rational function. So there are no negative exponents or fractions. So our first step was we rewrote all of the terms that had a negative exponent. So we said, well, we can rewrite x to the negative 1 as 1 over x. And then we can rewrite y to the negative 2 as 1 over y squared. And then keep x plus y. We still have fractions, so in order to get rid of the fractions, we found our LCD, which was equal to xy squared. It's equal to xy squared because we have to divide both x and y squared. However, and so we then simplified this these fractions up here. We flipped and multiplied, and we got our final answer. However, if you notice, our LCD consisted of the reciprocals of our fractions. In order to eliminate our fractions, we had to find the reciprocals of each one. So the reciprocal of 1 over x is x, and the reciprocal of 1 over y squared is y squared. But how did we get these fractions? Where did these fractions come from to begin with? Well, they came from the terms with the negative exponents. The terms with the negative exponents become fractions. They're the only ones that become fractions when we simplify them. And what do we want to do with fractions? We want to get rid of the fractions. So, instead of rewriting this whole thing into this more complicated version with the fractions on top of a fraction within a fraction, we can just use what we know to simplify this expression. So I'll show you what I mean. So if we go x to the negative 1 plus y to the negative 2 all over x plus y. Well, we know that the terms that are going to become fractions are x to the negative 1. That's a little blurry there. Let's focus. Okay, so we know that the terms that will become fractions are x to the negative 1 and y to the negative 2. That means we need to find the least common denominator of these two terms because they are the ones that will become fractions. So our LCD has to divide. So these are the terms that will become fractions. And the reciprocals, so our least common denominator is made up of the reciprocals of our fractions. So we have to find the reciprocal of each term. So the reciprocal of x to the negative 1 is x, and the reciprocal of y to the negative 2 is y squared. Because x to the negative 1 is 1 over x, and y to the negative 2 is 1 over y squared. So the reciprocals are x and y squared. All right, so now that we've found the reciprocals, we need to figure out what divides both terms. Well, we know that to divide x and y squared, our least common denominator is x, y squared. That will divide both x and y squared. Now that we have our least common denominator, we can simplify our expression by multiplying the top and the bottom by the LCD. So times xy squared over xy squared. Okay, so we can multiply it out. This first term is x to the negative 1 times xy squared plus, and the second term is y to the negative 2 times xy squared all over xy squared times x plus y. Okay. We can simplify this even further. Well, we have the same base right here, x times x. What can we do with the exponents? We can add them. So x minus 1, so x to the minus 1 times x to the 1, there's a 1 right here, because it becomes x to the 0. Minus 1 plus 1 is 0, and that's just 1. So all we're left with is y squared. Now this makes sense because we know that x to the negative 1 and x are reciprocals. Whenever you multiply a function with its reciprocal, it always becomes 1. Always. A function times its reciprocal always equals 1. So we know this becomes 1. We're left with y squared. What about here? Well, if we multiply y to the negative 2 and y squared, function times its reciprocal always equals 1. And we're left with x squared. And then down here at the bottom, x plus y. We can't cancel anything from the top or the bottom. So we can just multiply out and get x times x is x squared, y squared, and then x times xy squared times y. So over here, we multiply this first. We get x squared, y squared. Then y squared, xy squared times y is just equal to xy cubed. So and then we multiply this right here to get this. And that's our final answer. X squared plus y squared over. So you don't need, as you can see, you didn't need to turn everything into, up here, sorry. You didn't need to turn everything into fractions. This was just a way for us to see why we can multiply by the reciprocal, or why we need to multiply by the reciprocals to create our LCD. That's how we know, because when we turn into fractions, we saw that, oh, well, to get our LCD, we have to use our denominators here. And those denominators happen to be the reciprocals of our functions, of our fractions. All right? So to summarize, first, when we're looking at an expression with negative exponents, we know that the negative exponents are the ones that become fractions, right? The terms with the negative exponents become fractions. Then, because we know those are the ones that turn to fractions, we want to eliminate those fractions and cancel out the negative exponents. So we have to create a least common denominator composing of the reciprocals, because it's the reciprocals that will cancel out our negative exponents. So the reciprocal of x to the negative 1 is x. The reciprocal of y to the negative 2 is y squared. Remember, because x to the negative 1 equals 1 over x, and y to the negative 2 equals 1 over y squared. So we have to eliminate both, so we have to find the least common denominator. Our least common denominator that divides both x and y squared is xy squared. And now that we have our least common denominator, sorry, it's going out of focus. Now that we have our least common denominator, we have to multiply the top and the bottom by our least common denominator. Top and bottom by least common denominator. And then we just apply our exponential laws and we multiply it out. And the most important step here is that, remember, a function times its reciprocal is always equal 1. So a function times its reciprocal is always equal 1. And that's why that just went away, became y squared. Function times its reciprocal, always equal 1. That just went away and became, we're left with x squared. Multiplied out the bottom as well. And then we got this as our final answer.